Hello, everyone. My name is Sadeq. I'm a staff engineer and tech lead at Trade Republic. We are a bank, and we are also an exchange company. And what we do is basically what other banks do, but we are a neobank. So we have too few staff and lots of things to do. And the business is running smoothly, and suddenly we see that, oh, some query that up until yesterday was running perfectly suddenly starts acting up, and there's an incident. Okay, so the query may have taken a few milliseconds yesterday. This has happened. It took 2 hours to execute suddenly. Why? And people start investigating. So incidents for any company is a normal thing. So people start investigating. And quite a number of times, I find myself the elephant in the room. So they say, hey, Sadeq, come to our incident channel and tell us what's going on. So I'm a developer as well. I'm not DBA or anything, but I'm very in love with Postgres. So usually it boils down to statistics. And here's the topic that I want to talk about. It is about how Postgres counts without counting. So it is like this. Postgres has to devise a plan for the query execution, and usually it has to estimate somehow what is the best way to execute the query. And for that, Postgres internally gathers some statistics about your tables and your data. So here I want to show you how these statistics are gathered, what is behind the scenes, and basically everything you need to know about execution of a query and how the plan is devised. So this is going to be a live talk. Everything that I'm executing here, these are not slides, these are actually something that I'm executing via PSQL, which is a famous client for PostgreSQL. So everything here is running within PSQL. All of them are queries, and except small things like rendering images, where I call something from within PSQL to render an image, everything else is actually SQL queries. So this is the plan that we are going to have. I'm not sure if everyone sees everything on the screen. If not, please tell me. Okay, everyone sees it, great. So this is the plan. First, I will give you a very rough introduction to Query Planner, how statistics are going to be gathered. I will introduce a little utility function so that we can see everything more clearly. Then I will show you histograms, which are a very good tool that Postgres uses behind the scene to gather statistics and summarize your data. For a very short time, I will show you vacuum. It is a process that Postgres runs to do some stuff. I want to differentiate between gathering analysis and statistics and vacuum because they go together often, but I want to separate them. Then, finally, in stage 5, we reach the actual problem. I will create and simulate something that shows you why, when the statistics are off, Postgres can do strange query planning. And cherry on top, I will show you multi-column statistics. And finally, in the summary section, I will show you more stuff that you can follow. Everything can be downloaded from here, so you can scan here. Everything is in my GitHub repository. I have written two-part blog about it. The first part is already there. When the next part is published, I will also link it. So this slide will repeat. If you don't have time to do it now, you can do it later. So let's get into it. First, I want to create a table. I create a table with a single column. The column is called n. It is integer. I will insert 1,000 rows. The rows are numbers between 0 and 999, modulo 5. So modulo 5, it's either 0, 1, 2, 3, or 4. And because it's kind of distributed nicely, we have 200 of each of them. So 200 0 to 101, and so on. 20% of the data is basically one of these values. And I'm going to run turn off something called autovacuum. This is something that I want to talk about, and in the afternoon there is a talk to further tune it. Never ever turn it off. I'm turning it off to show the point. Okay, so over the course of this talk, we'll see why turning it off is a bad idea. Here I'm turning it off to show the point. Okay, so we insert 1,000 rows, and then I am running the queries with explain, and with explain I can see the query plan. So if I run select the star from T, you can see this is the part that I'm concerned with. Postgres absolutely has no idea at this point how many rows we have in the table. It estimates there are 2,550, if I'm not mistaken. Yes, so we inserted 1,000 rows, but its statistics are way off because I turned off autovacuum, which is in charge of gathering statistics. Now let's do another query, select the star from T, where n equals 0. As I said, we have inserted 200 of each amount, so we expect that the planner knows ahead of time there are 200, but statistics are off, so it is assuming there are 13 rows. And now, if n equals 10, we inserted rows that are modulo 5. We are sure that there is no data point n equals 10. But again, Postgres does not know that, and it says, I estimate there are 13 rows. Here you are getting my point, why it's important to know this, but as we go on, we can show this better. So let's take a look at some internal Postgres data structures. For example, here there is this table, internal Postgres table. Usually the internal ones are prefixed with PG underline. We are looking at PG underline class, which is where Postgres stores data information about relations or tables. Tables, indices, views, and things like this. And the important part is how many tuples or how many rows Postgres thinks this table has. And it's -1. -1 means I have no clue whatsoever how many rows are in this table. Okay, let's create an index. Usually indexes fix everything. So we create an index and we think, okay, we are fine, let's go. So we developers do this, and sometimes it's not fine. So let's create an index. Here I'm creating an index on the single column that exists in that table. Okay, fine, now Postgres knows exactly how many rows there are, but besides this query, that now Postgres knows exactly 1,000 rows are in the table, the other ones are way off. So you can see again, we had 200 per data point, like data point 0, 1, 2, 3, and 4. It says 5. It has no clue when planning for a query like this. Okay. So this was the first part. So turning off autovacuum and then creating the table, looking at the queries. Postgres has no idea. Creating an index. Okay, now Postgres knows how many rows are in the table, but when we query, it does not know how many of each. Let's go and gather statistics. So here, I don't show you one step. I'm dropping the table and recreating it. So recreating it is shown here, but dropping it is not here. So we do exactly the same. We create the table, we look at PG class, and now, maybe I should have gone one step too far. Let me run it again. Okay, so here I'm looking at a view that Postgres has called PG stats. This view is defined on top of PG statistics table. It is a nice view that shows information in a better organized way. And Postgres has no information, no gathered statistics about this table, because when I query this, it says 0 rows. So at the moment, Postgres has not gathered any statistics about this table. The keyword here is analyze. So when I analyze the table T, it starts gathering statistics. If you know explain analyze, this has nothing to do with explain analyze. This is just a coincidence that it's called analyze. So you can analyze a table. In this manner, you can tell Postgres, okay, gather statistics on this table. And this is the magical keyword that when I go to an incident, I say, please analyze that table. Okay, everything's fine, goodbye. This is exactly, so for 2 hours, people are in incident, why the query is slow, what can we do, let's create an index, let's change the index, let's drop it. It's not. Just tell Postgres to gather statistics. So if suddenly Postgres starts acting up, chances are, high chances are, that the statistics are off. So here I'm analyzing the table, and as you can see, after I analyze the table, without creating any index, Postgres knows that there are 1,000 tuples in the table. And now PGStats, which was about statistics, has a lot of information about the single column n. So it, for example, knows that the most common values in this column are 0, 1, 2, 3, 4. These are actually the only ones, but if we had thousands upon thousands of values, it finds the most common values and records them as part of the statistics. It has the frequencies for those. So we know that 20% is 0, 20% is 1, and so on. It has some other information like histogram. At the moment, it's null, but I will show you when the data set grows, it will start gathering histograms as well. And there are quite a number of other fields, but I want to focus on these 3 in this talk. And there are other talks at the end that I will point you to that you can look at it, but look at the other columns. But these are the top ones that we want to talk about. Okay, so we told Postgres gathers statistics, and now if I say explain, select the star from T, it knows there are 1,000 rows. If I say how many of them are exactly 0, Postgres knows that 200 of them are 0. And if I tell it how many of them are 10, we as the developers, we as the people who inserted the data, we know that there are none. It was modulo 5, it cannot be 10. But Postgres cannot prove this because Postgres gets a sample from the data. In that sample, it could not find 10, but it does not mean that mathematically it's impossible that the table has this value. So Postgres, in this case, instead of assuming there are none, it says maybe there is one. Let's just run the query. So this is the case unless Postgres can prove that there is no data. So if I said where 1 equals 2, this is mathematically impossible. The where clause where 1 equals 2, it's never happening. It would say there is no such row. But here, because it has gathered statistics. So, for example, if I look at this room, okay, maybe this section, I see 2 people. Maybe these 2 are students. Yes, I have this sample, but I cannot say the other people in the room, there are no non-students in the room. So I have a sample of the data. Based on that, I can do some reasoning. I cannot prove everything about the whole population just by sampling one part of the data. Okay, so after doing analyze, I want to do explain analyze. Again, unfortunate naming that we have analyzed here and analyzed there. These 2 have nothing to do with each other. With explain analyze, we run the query, and now we can see the actual. So we have both the planned part, Postgres planned and just assume that there are 1,000 rows, and when it actually executed the query, it knows that, okay, I encountered 1,000 rows. Doing with n equals 0, it planned for 200 rows, and it actually saw 200 rows. And doing with n equals 10, as I showed you, it planned for 1 row, and in the actual world, it saw no such data. Okay, so with explain analyze, we can actually see and compare. And if these two data are way off from each other, so one is, I don't know, 2,000, the other one is 2 million. This means that your statistics are way off, and Postgres could not have planned correctly. Okay, so we don't want to look at the explain analyze over and over again, so I will define a simple function. This simple function looks at the explain analyze, but the JSON format of the output. Why JSON? Because we can then look at various parts. So the things that I'm interested is the node type, the plan rows, and the actual rows. These are the things that I'm interested in. And the function looks like this. And it basically runs the explain analyze format JSON, and then extracts node type, plan rows, and actual rows, and returns the result. I called it C. This is bad naming. Never name your function C. But I wanted to be precise in this talk so that I don't take a lot of screen. So remember, the function C is like this. And now if we look at the output of function C, we can see the plan, the actual, and the estimate. So we will continue using function C from now on. And if you are a developer or want to be developer, you can define a similar function to have estimates. So sometimes you don't care about the actual count. You want an estimate of the actual count. So this function can help you if the statistics are up to date. So for example, you want to show you there are 1,000 results in your query. Somebody searches in Google. Google wants to show there are 2 billion. The user doesn't care if it is 2 billion or 3 billion. It's just a lot. So you can show around 2 billion results will be returned if you click next, next, next. Okay, so we defined the function. Now let's take a look at our histograms. So here I'm inserting 1,000 rows into the data. So not 1,000 rows, it's not exact. So it's like this. I do 1,000 iterations. In the first iteration, I insert 1. In second iteration, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, and so on and so forth until I insert 1, 2, 3, 4, 5 up until 1,000. So number 1 is actually inserted 1,000 times, number 2, 999, and so on up until number 1,000 is inserted only once. Why did I do this? I want to insert some skewed data. So you can see that this diagram, most of the data are gathered in the left-hand side. If we look at the median of the data, it is at 294. So like at 1/3 point, we have half of the data. So this is the skewed data that I'm inserting because I want to show you the histograms and how they work. So with this query, you can see where is the median. Just before this talk in the other room, there was a talk about analytical functions, and with these analytical functions, you can find median quite easily. Here, I'm looking at it, the median is 294. And we can query the data before, and before the median, we can see that 50% of the data, almost 50% of the data is before the median. Okay, now we are doing analyze on the table. This time I'm adding another keyword, analyze verbose, where here analyze shows me more info. So what it's doing behind the scenes. And it's looking at the table. The data is gathered in several thousand pages. Postgres inserts data in pages. Each page is 8 kilobytes. It found 500,000 rows. There were no dead rows. We will talk about dead rows in a while. 30,000 rows were picked as sample. Let me check. Yes, 30,000. So out of 500,000, a sample of 30,000 was taken. It's like from this room, I pick like 6 people as a sample and then start gathering analysis based on that. We will talk about how this sampling size can be affected. How can I get more bigger sample size? How can I get smaller sample size? And how does it affect your statistics accuracy? But before that, I think most of the people here are students. It is very interesting. The algorithm used here is very interesting. It is called reservoir sampling. It is like this. I want, if there are 1,000 people, no, it's too much. Let's say there are 100 people in this room. I want to get a sample so that everybody is picked with probability 1/100, so 1%. But the interesting part is that I don't know how many people are in this room. So I want a sampling algorithm that picks people without knowing, with a given probability, but without knowing how many people are there. It's very interesting. If you're interested, you can take a look in Wikipedia. The algorithm is explained there. So here, if I run the query, I can see that it does a sequential scan. The estimate is 200,047 or 247,000, sorry. The actual value is also given here. So the number of rows that are, whose n is less than the median. Let's do another analyze. And now because it takes another sample, the estimate differs. So you can see the actual doesn't change, but the estimate differs because it takes another sample. And this is important. Every time you do analyze, it takes a new sample from the data, and based on that sample makes a separate estimate. So what are gathered in the histogram bounds? Histogram bounds is actually an array. And I wanted to show this array in some beautiful manner. So I defined the function beautify, which shows 20 rows per, like 20 is defined here. I'm not showing the function to you. You can look at the source code on GitHub. It's not important. We just want to see, visualize somehow the histogram bounds. So you can see 20 per row. Can you tell me how many are there if there are 20 per row? Like there are 5 rows or 5 rows plus just one value. So there is 101. There is a target to gather 100 values, but 100, like the beginning and the end, should be counted. So there is extra 1. And what are these values? So Postgres gathers a sample from the data, and based on that sample, it creates this. It means that between 7 and 27, let me just select it, 1% of the data is here based on that sample. It is not accurate, it is just statistics. Then 1% of the data is here. And so on and so forth. Because the data is skewed, we expect that initially the, like you can see here, between 7 and 27, there are 20. So here, but between 915 and 999, there are more. So initially, they are smaller, and as we go forward, like 1% of the data is in a bigger range. Of course, this is a little bit hard to understand, so what I want to do is to change this. The default statistics, there is this default statistics target parameter, with show keyword, you can show it. It is by default 100, and we can change it. So whenever I do this analyze, we saw that it gathers 30,000 here, but if I change this default statistics to 2, now it's only gathering 600 rows. Of course, a smaller sample means the algorithm runs faster. So if you have huge table, you can lower this statistics. This means that the sample is smaller, so it's faster. But on the other hand, a smaller sample, less accurate planning, less accurate estimate. So let's see this. Here I'm showing you the histogram bounds. So we told it the default statistics is 2. It means that there are two ranges. The first range is between 2 and 300. The second range is between 300 and 975. So that table that initially had 101, now it has 3. Not only it gathered a smaller sample, this is also affecting the histogram bounds. So looking at the actual minimum, median, and maximum, we can see that the lower bound here is close to minimum. So it took a sample. On that sample, the smallest number was 2, while the actual smallest number in the database is 1. The upper bound for the sample was 975, while the maximum data is 1,000. And the median, the value in the between, you can see it is close, but it is not accurate. So we have a smaller sample with less accuracy, of course. So let's try doing some C function calling. Here I'm telling how many rows are less than the median, and I expect that it is close to the value, the actual value, because it knows the median, as I showed you. But if we deviate from the median, now the estimate and actual drift apart. So the smaller sample size means that the estimate will be a little bit off. Of course, it's not 100% off, but it's a bit different. So the default statistics target is a global parameter for the database. It will affect all of your tables. But of course, you don't have to affect all of the tables. You can affect the amount of statistics gathered per column. So you can do alter table T, alter column N, and then set the statistics that you want. The target statistics, now I'm setting it to 10. And now if I do analyze verbose, and you can see it gathers more rows. Previous time it was gathering only 600. And now the estimate is much more accurate because it has gathered a bigger sample. It now has more histogram data. If you want to reset everything to default, you can do that. Reset this, and we can see that the default statistics is now back to the value 100. You can do alter table T and then set the statistics target to -1. This sets it to default. In Postgres 17, which was released, I think, in September, around September, they added the keyword default. So instead of -1, you can now set it to default. Of course, not a big deal, but more easy to read and understand. Okay, so now I set it to default, and now if I do, again, analyze, it goes back to 30,000 as it was initially, and we can see that the histogram bounds now has, again, 101 rows. Okay, so we saw about this, and let me check the time. Yes, okay, halfway there. So the topic that happens a lot is people confusing vacuum and analyze. I just showed you that analyze is for gathering statistics on the table, but what is the vacuum command? So here I'm deleting a lot of rows. And after doing analyze, we can see that it says there are some live rows and there are some dead rows. So similar to, let's say, Windows operating system, when you delete an object, it goes to recycle bin. Postgres does not actually delete the data. It just marks them in a special manner. So we can say this is dead, but it's still there until a special process is executed that reaps those dead rows. So every time now I run analyze, it still sees that there are some dead rows. And if I do vacuum, so you can do vacuum verbose to see more information. Of course, it's not required. We can see that there are some tuples or some rows ripped from the database, and now they are gone. So if we do analyze again, we don't see those dead rows. So vacuum is another operation, another maintenance operation besides analyze. And the thing is, they can be combined. So it is possible to do vacuum and analyze together, as you can see. It goes over the table, it rips dead rows, and also it gathers the statistics. Because these two can be combined, a lot of time people confuse them. So I say analyze the table. The developer tells me, why should I analyze it? There are no dead rows. Analyze has nothing to do with dead rows. Analyze is about gathering statistics. Vacuum is about reaping dead rows. Okay, so this was about dead rows, the vacuum operation. Now we reach at the stage that I want to show you a rather contrived example, but real-world examples exist, and I've seen it many times. So let's try to see what will happen if we have stale statistics. So again, this is a contrived example. I am constructing in a way that I somehow trick Postgres into having wrong statistics. But again, this can happen. Creating a table, setting autovacuum to off, inserting 3 rows into the table, 0, 1, and 3, running analyze. So now Postgres gathers the statistics, and then again inserting more rows. So now the table has 1,000 rows, but the statistics are stale. The statistics are gathered when the table has only 3 rows. So if I'm in this room and there are 2 other people with me, and somebody asks me how many of them are European, let's say, I can say, are you European? Are you European? And then gather the statistics. I don't have to get a sample if it's so small. But if there is like, I don't know, we are working in a country and we want to know what percentage are belonging to that country, what percentage are foreigners, we cannot just go to every single person and ask them. We have to somehow gather statistics. So when Postgres gathers the statistics and then wants to run a plan, it considers what is the best option. Now, as we see here, the statistics are gathered when there were only a handful of rows, and then more rows are inserted. So the data is very, very stale in the statistics table. The actual data is okay. Now, I'm telling Postgres, select the star from this table where n is less than 5. Back when it gathered the statistics, there were 0, 1, and 2 in the table, less than 5. So it thinks a little bit and says, okay, why should I use any kind of other plan? I can just do sequential scan. Let me do now analyze again. Now it does index-only scan. Because there was an index, there were a lot of data, but why use an index? Index is like a redirection. If you have a 2-page book, you don't need to go look into the index. You can just look at those pages. If there are so many data points, it has to look into the index. This is exactly why it suddenly takes 1 hour to execute a query. We have many data inserted. Statistics are outdated. And because of that, Postgres just selects a wrong query plan and incident. So this is super important to have always up-to-date statistics. Okay, should I, as a developer, go and run analyze every few times that I inserted several rows or updated them or deleted them? Fortunately not. Postgres has a facility called autovacuum. Autovacuum does 5 things. One of them is doing auto-analyze. This is where the confusion comes from. It's called vacuum, but it's also doing analyze. And if we look at the processes that exist now, so it is one of the processes, one of the few processes that Postgres launches during the startup. It works like this. It gets up, so it's not running always, but it gets up, it looks around. Which table requires my assistant? Oh, this table. Since last time I executed on it, this table has quite a number of changes. Let's do analyze again on that table. So Postgres keeps track of the number of rows that are inserted, updated, and things like this. When analyze gets up, oh, this table is eligible to do analyze, this table is eligible to do vacuum, and certain other processes. So autovacuum gets up and does it for you. So let's see. If we look at the nap time, by default, it gets up every 60 seconds, every 1 minute. This is not accurate. So it does its thing, then goes to sleep for 60 seconds, then gets up again and does its process. So it is not always running behind the scenes. This parameter, the context is SIGHOP, so we cannot just set it per session. It is set per database, and we have to reload the database. To do this, we have to alter system, set the nap time to, say, 1 second. This is not wise. On a big database, it will be running frequently. But I want to show you, I don't want to wait 1 minute. So I'm setting it to 1 second, reload the config. Now that the config is reloaded, if I look back at the auto vacuum nap time, it's now 1 second. Now I create a table. By default, it's on. I just wanted to be explicit here to show it to you. There are quite a number of parameters that you can set. So when is a table eligible for auto vacuuming? When there are a certain number of changes. Those certain number of changes, by default, if I'm not mistaken, if at least 50 rows are inserted, plus 10% of the table has changed. Here, I'm adjusting this if at least 0 rows are inserted, so I don't care about the number of rows, the numbers. Oh, sorry. If at least 0% of the table has changed, so I don't care about the percentage, and at least 1 row is inserted. Okay? And then I insert quite a number of rows, 100,000. And we can see the last time it's auto-analyze is set. So I was a bit slow. If I did it immediately, you would have seen that it's null. Then the next time I executed it, you would see that now it's executed. But anyway, the thing is, there is a table that you can see actually when it was last executed. And if it's null or too far in the past, there's something wrong with auto vacuum. We have to adjust it. Again, there is a session in the afternoon. I think it's one of the last sessions where auto vacuum adjustment parameters are explained. From a FinOps point of view, how well we preserve money, but we should also be accurate. So now I did not run analyze on the table. Auto analyze did it, and we can see that it has pretty good estimate about the number of rows for my query. So, last topic I want to talk about is multi-column statistics. Let me just one more time check. How much time? 10 minutes? Or 10 minutes, okay, we have time. So Postgres, what it does, always, it has per column statistics. Sometimes there are dependencies between 2 columns. And when there are dependencies, it doesn't know. It just treats them as independent. And like you know about probability, when they are independent from each other, the probability of each one is multiplied. So by default, Postgres always assumes that they are independent. I'm here inserting 2 rows, n and m, and they are totally dependent. So one of them is n modulo 2, one of them is n modulo 4. If a number is divisible by 4, It is divisible by 2. So these two columns are not independent. They are totally dependent on each other. Running analyze on the table and then doing some queries. First, I'm asking how many have n equal 1. It says the exact number, the estimate and actual are correct. How many do we have m equals 1? Correct. But if I AND them together, how many do we have that n equals 1 and m equals 1? These are not independent. If some number we have, like it's modulo 4 equals 1, then it's modulo 2 equals 1. So they are not independent, and you can see because it multiplied the probability, the estimate is quite off. And what we can do here, first, index does not help. So if I create an index on the composite n and m, it doesn't help. The index does not help here because the index is not used for planning. Of course, sometimes it's used for planning, but we'll talk about it later. Here it's not used, and Postgres allows you to create extended statistics, meaning statistics on multiple columns. So if you as a developer know that these two columns have values that are dependent on each other, you can define extended statistics. The syntax is something like this: create a statistics, you give it a name, you give it on which columns from which table. Postgres allows you to define 3 types of extended statistics. I don't have time to discuss them. Read them on your own. Then we have to analyze the table, and now it gives us pretty accurate estimate. And if we look at where the statistics are gathered, this is the view on top of some table, PG stats extended. Here we can see what kinds of things are gathered. For example, how many distinct value we have, what kind of dependencies we have. So here it says from 2 to 1, there is 100% dependency. So if we know column 2, the value of column 2, we can with 100% certainty say what is the value for column 1. If we know what is n modulo 4, we can say what is n modulo 2. What are the most common values? So 3 types of statistics are gathered here. Look at the documentation or some other talks I will tell you, but basically that's it. So you can easily define extended statistics. And with that, we are at the end of the talk. I want to give you further references if you are interested to read, and then give you a summary. Here is one of the worst things. I could not zoom it properly, so yeah. Here are 4 talks or 4 weblogs that I really liked, and I think you can enjoy. Of course, the image and the whole thing is on my GitHub. You can download it from there, but anyway. First one, a deep dive into Postgres statistics. This was a rather shallow dive into Postgres statistics. I did not give you how everything is computed. I just say, okay, statistics is gathered, and then somehow Postgres uses that statistics to plan. But the first talk, it was from PGConf EU this year. It was in Athens. I lost track. But it is going a deep dive and tell you how those statistics are used. The second one is a PG hint plan. This is by Frank, and he has a lot of discussions here. You can basically give hint to the planner. Sometimes there is absolutely no way to tell Postgres about the statistics. For example, there is a join between two tables, and the columns of those tables are correlated. You cannot create extended statistics on columns from 2 tables. There is no way. At the moment, it's impossible. So he tells you how this can be done using PG hint plan. Word of warning, some people are not a fan of PG hint plan. I told you index has absolutely no way of helping planner. That was kind of a white lie. There is a little bit possibility that index helps, and here this blog out of range statistics, it tells you how index can help with that. And finally, there's an interesting blog about how adding an extended statistics helped by 3,000 times speed up. So here it is. The key takeaways, and then I'm done. Statistics are very important. I hope if you take nothing from this talk, I take this that statistics are super important in the planning and they should be adjusted. Sometimes we will have incidents. Autovacuum does a lot of things, 5 tasks actually. One of them is gathering statistics. There are 2 possibilities. First is to adjust it. If you have a huge table, default auto vacuum setting, 10%, is not good. It should be adjusted. Another possibility is to run it manually. So one of the things that we do on one of our databases is to run it manually as well during the time that the load is not so high. We use pgcron, which is a scheduler for Postgres. We do this. And there are a few occasions you should run analyze. Whenever you do major version upgrade, Postgres loses its accuracy of statistics. So if you go from 16 to 17, immediately do analyze on the database. When you switch to a logical replica, so not every replica is eligible, it should be a logical replica. And whenever you create indexes on expression, so Postgres allows you to create indexes on expression, and you should run analyze to gather information on that. There should be a monitoring. We can take a look at pgstat user tables to see when was the table last vacuum, last auto vacuum, last analyze, and last auto analyze. And finally, consider using extended statistics when you know there are dependencies between the columns. And by that, I think we are at the end of this talk. And do we have time for questions?
Moment, mám tady tu vychytávku od Michala.
When the auto vacuum is turned off for the table, what is the source for the planner for the random numbers? Because it can still be 1,000 million.
Yes, so that's the reason it should not be turned off. When it's turned off, I show that the statistics are way off. So it says, for example, there are -1 rows in this table, means Postgres has no way knowing it, and it just uses some wrong thing to do the planning. Auto vacuum can be turned off when you do loading of a huge data. So for example, you have a database which is not under load. You want to load 1 million rows, 1 billion rows in it. For initial loading, turn off auto vacuum, load it because you don't want auto vacuum to kick in, and then turn it on again. Otherwise, as I showed you, it's wrong. It's very bad.
So there is no second level statistics which are always turned on. Oh, okay.
Okay, thank you very much for your attendance. Wish you a nice
Thank you.